Welcome back. So now we're looking at multiplying by conjugate binomial pairs. And we really need to discuss what this conjugate binomial pairs is. Take a look. I have two conjugate binomial pairs listed below. Look at them for a minute. Tell me what you see. Tell me what you notice. Basically, these are conjugate binomial pairs. You have the first term, the same first terms, you have the same second terms, but they have a different sign in between them. That's all. Okay? Same first term, same second term, different sign in between them. This is going to do something interesting. This is going to do something very interesting. Now, you already know, because we've talked about this in class, this is a difference of squares. This is going to give you a squared plus ab minus ab minus b squared. And these guys are going to cancel each other. It's going to leave you with a squared minus b squared. Do you understand what that's going to do in this situation? If I start off with root a minus root b, and I multiply it by root a plus root b, and if I'm going to get a squared minus b squared, which is the first term, right? So the first term squared minus the second term squared, and since the square root of a squared is opposite operations, so it's going to be a, and the square root of b squared are opposite operations, it's going to leave you with b. Notice we went from radicals, to non-radicals. That is cool, and we're going to make use of this a lot. Okay, so multiplying by conjugate binomial pairs. We can do it the long way. Root 7 times root 7 is root 7 squared plus root 35 minus root 35 minus root 5 squared, which will be 7 minus 5, which will be 2. Okay? Or we can start simplifying it if we know what we're doing. We got root 3 times root 3 will be root 3 squared. I'm going to get positive 2 root 15. No, sorry, we're going to get negative 2 root 15. I'm going to get positive 2 root 15. And I'm going to get negative, this one's, let me do this. I'm going to get the first one squared, subtract the second one squared. How do I do that? I followed this idea. If it's a difference of squares, then it's going to be the first term squared subtracted the second term squared. This is a difference. These are conjugate pairs. So it's going to be the first term squared, root 3, subtract the second term squared, 2 root 5. Now you got to be careful when you do this. Root 3 means root 3 times root 3, which is 3. But 2 root 5 means 2 root 5, 2 root 5. When it's squared, there's 2 of them. So it's actually 2 squared, which is 4. Root 5 times root 5 is 5. Now this seemed very convoluted and hard to do and took up time. You might have said, I'd rather just do this, you know. Thanks a lot, Mr. White, but you know what? I'm just as happy. I'm just as happy to do root 9 minus 2 root 15 plus 2 root 15 minus 4 root 5 squared. That'll be 3. They cancel each other. That'll be 4 times 5. That'll be 3 minus 20. And I think that was the same answer I got before. It was. I just never made it negative 17. And this is negative 17. And I'd say to you, you're probably right. But until you get good at it. So let's see me being good at it this time instead of explaining it. Okay, so it's going to be the first term squared, and it's going to be subtract the second term squared. The second term squared, I'm thinking in my head, so it's the 2 squared, which is 4, the root 5 squared, which is 5. And so that's what you have to compare to that. Anyway, Okay, so that was conjugates, multiplied by conjugate binomial pairs, and then we'll come back with dividing radicals.